Hi, I'm Todd Cook. Welcome back to the kitchen for another episode of Polymer E-Club's Ask the Cook. We're here to talk about polymers and polymer application to help you answer the question, what do you need to know to add polymer skills to your career? Now, simulation, one of the most amazing things about the computer age has been the creation of simulation tools that can simulate the manufacturing process, stamping, thermoforming, injection molding. A simulation is created by developing a model that represents the part to be produced in enough detail to use the constitutive equations, that's the physics, and the equations of chemical reaction, for example, or even the equations of motion, among many other details, to handle things like the plastic deformation of parts, nearly as they will occur in the actual process, but before the mold or die has been created, before the investment. Being able to see how the part geometry and material properties will impact the performance and manufacturing processes before the actual investment occurs is just the most powerful way that I can think of to head off common quality and repeatability problems before building them into the part or the tool design. Doing this work beforehand can illuminate some opportunities as well. I remember doing a simulation for a major television manufacturer, and this was at a time when ever larger size products was the driving force between competitiveness, and most of the production was not domestic in the United States, so there were a few domestic players left, and they were very competitive over size. And they were worried that as they made larger and larger parts, they would have to buy bigger and bigger presses, and the capital cost was an overwhelming part of that consideration. What we were able to show them is that the power law behavior that was common in the material that they used allowed you to push the material into the part a little faster, get a little higher shear rate, drop the viscosity, and reduce the response of the injection molding machine. So you could reduce the clamp tonnage. Not only were they able to reduce the clamp tonnage for their existing product, but they were also able to run the next generation of slightly larger product without buying new presses, a massive savings. And that kind of proving those kinds of things, working out the errors beforehand and looking for design flaws and being able to fix them, make the simulation process just worth the investment. So knowing that simulation can help you in product design and process improvement, that's working knowledge. Just what you get when you watch us here at Polymer E-Club, Ask the Cook. Don't forget to like, subscribe, turn on notifications, and share if you appreciate the content. Also, you can follow a link in the description to learn more about Polymer E-Club and how to get involved. I'm Todd Cook for Polymer E-Club's Ask the Cook. Thanks again for watching.